Hello everybody, this is Mike here. Just going to go ahead and we're going to have a little quick tutorial over a program that Professor Dewick has you download. Actually, it's an M file, but when you run it, it's a specific program that is good for working out uh, slope fields and differential equations. So as you can see here, I've opened up my MATLAB and I went to my current folder where your root folder where everything is, and I'm going to take Dfield 8, I'm going to double click that and open it up. And as you can see, it pops right up over here. And yeah, it's a big program. It's got a lot of stuff in there, about 4,000, close to 4,600 lines of code, just under 4,600. You do not want to edit this stuff. Don't mess with it. It's if it has if it makes one mistake in there, you are done for. So what I'm going to do is I'm going to scroll this right up like this, just so I have a small chance of even putting my cursor in there. I don't know if anybody's ever done any coding, but you mess one thing up in coding and you'll spend forever trying to figure out what the mistake is. So after opening this up now, go right back down, put your cursor there in the command window if you'd like, and we're gonna go up here. We're gonna hit run. All right, and as you can see, it's gonna say right there, run Dfield 8. So that's exactly what we're gonna do. We're gonna click that, and boom, gonna open up this nice little window and make that larger for you guys. And let's see here, the what is in this window. Okay, perfect. So we got our differential equation. So just as we learned in class, uh, you set up your dy dt or your dx dt over here, and then right here is going to be the actual the actual function that's taking place, or the actual equation that's happening. Um, you can tell right up here you got that little prime, which as you all learned in calculus 1, y prime is equal to dy dt. It's just difference of notation. I believe the prime thing was I don't know who came up with the prime notation. I know that Leibniz was the dy dt guy. So what we're going to use though is our equation that we had in class. For an example, it was y prime, or dy dt, is equal to 2 minus y. And it is a function that, when integrated, uh, has an independent variable of t. So we will go ahead and say that the independent variable is t, even though t is not present in here in the differential equation. So you still want to put that down. It helps label your your x-axis, I suppose. And yeah, that's what we're going to put. So we got a nice little differential equation written right there. And for our window values now, this is really what this is. We can go ahead, and we already know how the equation works, so we can say that we don't need to go to negative t. A lot of times too, t represents time in differential equations, and you don't really have negative time, so uh, it just makes sense most often to start with something like a 0. In this specific case, it's going to be something that won't be difficult to understand. And let's go ahead and say I don't know, our max t goes up to, let's say, 8. It really doesn't matter. In fact, it could go up to infinity. We're going to see shortly here, just as we did in class, it doesn't matter at what time you happen to be. All the slopes are the same. So then now right here we're going to choose our different y values. If we look at the differential equation, it's kind of nice to try and think ahead and think about what you're gonna, where the important spots are. Where's this differential equation gonna do weird things? Since we got a rather simple one right here, to me, I look at this and I go, well, if y equals 2, I'm gonna have 0, so I need to, maybe interesting things happen above 2. So let's go and let's say I go to 6. I don't know. And then right here, once again, there's not much going on with this thing, but if y equals 2, you get 0. So maybe interesting things happen also below 2. Below 2. Let's just say negative 2. I don't know. I mean, I do know, but you never fully know if you've got other equations that you've got to work out or something. maybe something that has a polynomial in here. You never really know. You got to take that and break it down and figure out all of its roots and where the interesting things happen, right? Anyway, so now you're probably wondering what's this middle section? Well, I'm assuming, as it says right here, parameters and expressions. I'm assuming this is stuff where you can set limits on the equation. Be completely honest, I don't really work with this. I've never used it, and I'm not going to pretend that I know what it is, and I'm not going to explore it today. The point of this video today is to work with just Dfield 8 in the context that will help you as a student for differential equations. So now we've got everything all written out right here. We're going to go ahead and we're going to hit proceed. And voila, look at that. Oh, we got this nice, gorgeous slope field. That is just beautiful. You know, we can go and make it nice and big like that because we're not going to really come back to this anyway. So, yeah, let's expand that out. So just like what you drew out in class, if you were in class on last Thursday, well, it may not be last Thursday when you do this video. Either way, when you were in class, we had to draw out we had to draw a slope field by hand. And you know, it's good. It's good to learn it by hand. But now that we live in the future, it's nice to take trivial things that don't really require, you know, tons of thought and make a computer do them. And that's exactly what this is for. As you can see, it maps out all these nice little dashes, which represent the immediate derivative, I guess, or the slope at that specific point. So based on our equation right here, you know, 2 minus y, if you got a really big number, even though 6 isn't that big, but if the number is going up, you know, you can get a really negative number, it looks like. And same is for, you know, the converse of that. If you go really far negative, you're going to get a really big number. So what's that? What is that going to mean? It means down here, your slopes are going to have a greater positive value, and up here, your slopes are going to have a greater negative value. Either way, it looks like everything is moving in a general direction that goes towards 2. It's kind of cool. And if you recall, you know, there's no t right here. So what does that really mean if there's no t in the actual derivative or in the differential equation itself? Well, the slope, no matter at what time, you know, look at it, I'm right here at t equals 4. It looks like the slope at 5 is the same slope at 6, or excuse me, the slope at y equals 5 is the same all the way through it for all time t. So it never changes. At least the slope doesn't change. The equation does. But yeah, that's, you know, that's real nice. It's a nice pattern to recognize that. Now, you're going to see a little bit of the power here of Dfield 8. I'm going to go ahead and you can actually click on this graph and it will draw out a solution for you. So if you look down right here, there's this little cursor position, right? It tells you your coordinates that you're at, and you can get pretty darn accurate. So let's say I want to go ahead and do at time equals 2 and at y equals 4. Well, as you look at those numbers, I got 2.02 and 3.99. You know what? That's good enough for government work. I'll get that done. Look at that. I can click that just with my mouse, and it draws out a solution curve, which you know, does as we had discussed in class. It asymptotically approaches 2. So I go and I can click everywhere actually, and I can do this. It's really nice. You know, I could have infinite many solutions, which is what exists with this kind of problem. As you can see now, my graph and my everything's looking a little polluted. You know, it's just too much gunk going on. So I'm gonna go up to edit. I'm gonna scroll edit. I'm gonna scroll down. I'm gonna hit erase all solutions, and boom, look at that. All solutions are erased. Once again, I'm gonna go to edit, and I'm gonna hit erase all solutions, just like that right there. Cool. Now, let's say I want to be exact though, you know, because when I'm sitting here floating this, this cursor around, if you look down here, like I said, at the cursor position, it's kind of difficult to get it exact, right? Well, you can't actually get it exact. You just go ahead. You're going to go to options. So what did I just do right there? You're going to go ahead and open up our options, and you're going to click keyboard input. Just like that. Let's make that nice and big. Right here. And look at that. You are setting up what? Well, initial condition. This is your initial value problem, your IVP, the thing that we've already been talking about. And let's just say at I don't know, like time equals 3 and what are our y values over here? It's like time equals 3 and at y equals 5. Let's say that. So 3, 5, and let's hit compute. Look at that. It gives you the exact solution curve for any given time. Let's do another one. Let's say at time equals 0 and at y equals 2. Oh, whoa, whoa, oh yeah. Oh, hey, look at that. That was expected, right? Because of our initial differential equation. 2 minus y, and we let y equal 2 is 0. And if the rate of change at 2 is 0, then it stays 2 forever. So 2 for all time t. Kind of cool, huh? Anyway, we're going to close that out. And yeah, that is just the beginning here of what you can do with Dfield 8. I hope I can put together another video here and make it nice and quick, so that way you guys can go and play around with a little bit more with that. But yeah, there are some other things in here that are pretty cool. We'll get more to that a little bit later.